Ladies and gentlemen, hello and welcome back once again. It is 4 o'clock Eastern Time on a Wednesday, and these days that means it's time for Hot Technologies. Yes, indeed. We're talking about cool stuff today. Of course, I am your host, Eric Cavanaugh. The title for today's show is The Key to Effective Analytics, Fast Returning Queries. That's right, folks, we all want fast. Who doesn't want fast? There's a slide about yours truly. And enough about me. Hit me up on Twitter at Eric_Cavanaugh. I'll be happy to connect with you there and have a conversation in social media. It can be fun. Just don't talk politics. So the year is hot. We've been talking all about different analytical issues this year, and the one topic for today really is just central to getting the job done. I remember it was probably 5 or 6 years ago that I first heard someone use the expression, quote, have a conversation with your data. And even though it can sound a bit cheesy, the point is that if you cannot have an iterative experience with your data, if you cannot quickly amend your queries, send new queries, get answers back fast, then you're not having a conversation with your data, and the whole analytical process is truncated. So that's not good. When you have a conversation with your data, what that means is you're able to go back and forth, and in my opinion, that is when you find the insights, because very rarely are you going to come up with the perfect query the first time. Unless you're the Mozart of analytics, and I'm sure that person is out there, you're going to have to spend some time modifying, adding some dimension, trying to fine-tune what it is that you're looking for, because, again, these are not tremendously wieldy environments that we're dealing with in the world of analytics. We're dealing with very unwieldy environments and very complex and multidimensional environments. And so the whole idea of the webcast today is to talk about how to enable that kind of iterative interaction with your data. So we have 3 presenters, of course, in Hot Technologies, as opposed to the briefing room. We have 2 analysts. They each give their take first. Then the guest comes in, gives their presentation, and we have sort of a round table. And you, our audience, can play a big part in that. So please don't be shy. Send your questions in at any time. Use the Q&A panel if you can. Otherwise, the chat panel is fine. I'll try to monitor both during the show. And we do record these, so if you miss something or want to share it with your colleagues, come back later. We post them at techopedia.com and also at insideanalysis.com. And with that, I'm going to bring in the smart people. I'm going to hand it off to Dr. Robin Bloor. Let me give him the keys, change presenter, and there you go. Robin, take it away.
Okay, thanks for that intro. I had a chat, it's about a month and a half ago, I had a chat with a developer who's actually a DBA. He isn't really a DBA. He was a DBA at a particular company, and he was the only person that could actually make the queries perform. But he got sick of doing that because he is actually a fairly smart developer. So he left. And he has to do a kind of a couple of days every month for them anyway, because they couldn't find anyone to take his place, and they haven't got a clue what the database does or how to tune it at all. And I was kind of thinking about that, and just, you know, they didn't really have an IT department, but this guy that was doing support for them, actually it was DBA work that he was doing most of the time. So, for sophisticated databases, Oracle, SQL Server, DB2, all of those big expensive ones, database tuning is a tough job. It's a secure job as well. And the reason really for saying this is that it's a changing landscape. I'll kind of go through this. You know, relational databases, the big picture is that relational databases still dominate in popularity. They're likely to dominate for a long time to come. Yes, there are other databases now that get more airtime. But, you know, when you actually look at what's going on out there, Oracle's doing most of it, and Microsoft SQL Server is second. And there are various things happening in the cloud that may come up to challenge those. But they're the big giants in the game, and they're the databases that you can use both for OLTP and actually data warehouse type workloads. Alternatives are normally used mainly in analytical environments, and then normally it's determined by the data as to why you would choose that rather than relational, and mostly people don't. So companies tend to standardize on a single database. I came across a company recently that had over 5,000 instances of Oracle. And I kind of, person I was talking to from that company, I kind of asked them about the DBAs. They said they had about 10 DBAs and about 30 databases were being looked after. And the rest, Oracle was just being used as a file system by and large, or there was very little stress on the data from the applications that were using them. But I just kind of amazed me, 5,000 instances of Oracle, and by the way, they had an Oracle site license, well, you know, corporate license, obviously, but they also had other databases because sometimes, you know, applications come with a preferred database. So it wasn't like Oracle was the only thing. And worth mentioning that neither Hadoop nor Spark is actually a database, and it'll be a long time before they acquire what I think of as a database rule. Good for data lakes, of course. DBA activities, probably Bullett's going to say an awful lot more about this than me. I'll just run through them. These are what I tend to think of, you know, what the DBA does. They install, config, upgrade, do license management. They do a lot of ETL and replication work in one way or another. They do storage and capacity planning. They do troubleshooting, or they're part of the troubleshooting team. Performance monitoring and tuning is pretty much most of their activity, but all of this other stuff, it's not small, you know. Security, they're responsible for backup and recovery. They ought to be involved in software test systems, and they could be involved in data lifecycle. Performance. When I used to be one of these guys, and when I was running and tuning databases, this is how I understood it. You know, there's the CPU, and in one way or another, in our day, the CPU was pretty much normally idle because it would be one of the other two, or well, one of the other bottlenecks that would actually be causing the problem. Memory, thrashing and fragmentation, or disk I/O saturation. Sometimes network overheads if you're running in multiple nodes of a network, and you could actually run into locking problems. That was the world as I saw it. I took a look recently at Oracle and the number of tuning parameters that there are in Oracle. It was over 300. You know, and if you actually think about it, a DBA that really knows what he's doing has to have some idea as to why you would ever mess with any one of those. So it's a complicated job, you know, and it's made more complicated by this. You know, right now we've got CPUs, but the CPUs already exist with GPUs on the CPU or with FPGAs on the CPU. So there's a kind of cross-breeding going on of what actually happens on the CPU. CPUs became multi-core a long time ago. Actually, I was no longer tuning databases when that happened. I have no idea what difference it actually makes now that I think about it. We've got, you know, 3D Crosspoint and IBM's PCM coming up as an extra layer of memory. We've got SSDs, but you know, that are replacing spinning rust. But the SSDs can be varying in speed. With some you can have parallel access and it makes them go incredibly fast, close to RAM speeds. And you've got all of the parallel hardware architectures. And this is all, you know, the costs are falling, which is a really nice thing. But this is all making, you know, if you take the next release of a database and then you start implementing on machines that's even some of this, you've actually lost any gut feel you might have for the way that data behaves, because the latencies are just very, very different. And here, you know, you've got 4 layers rather than 3 layers of storage. Database issues, you get database entropy, just proliferating instances is very common. database being used as cupboards, which is what actually that example I gave was. Very few databases are self-tuning, and the ones that claim to be self-tuning are not actually that good, you know. But the other thing is very few databases are properly tuned. And it's a tough job being able to balance workloads. I mean, when you think about a database, what a database may be doing over a 24-hour period, the workloads may be very, very different that the database has to handle, particularly true with data warehouse. And therefore, tuning that is not a trivial matter, you know, because what you're doing is setting tuning parameters that have got to cater for a whole range of workloads at a given point in time. It's a tough job, basically. And SQL needs to be tuned, particularly for SQL joins. They can be extremely, you know, resource-consuming. And if the database has materialized views, to be honest, you should be investigating the use of those because they make everything go incredibly faster. And that requires somebody that understands the workloads and understands the SQL traffic and so on and so forth. And most companies employ very few DBAs, very expensive. I've known fairly large companies with like 3 guys, you know, massive number of instances. So really, they cost a lot. It's a hard job in terms of the complexity. They need tools. And I think that's all I've got to say. Oh, yeah. Let's hand on to Des, see what Des has got to say.
Thank you, Robin. So this is a massive topic. I'm going to keep to the things that I think that are effectively day-to-day challenges that we face because, you know, let's face it, there's an entire library of books written on this topic. Who hasn't gone to a technical bookstore and found walls and walls of books written on just the general topic of database performance and database tuning and monitoring? And sometimes it's a great way to kill time. So the general topic of getting performance queries, there are a number of different parts of the organization that sweat this topic. At your end user level, in my experience, you know, people just experience it as performance. Things are slow. Spinning wheels take a while to get queries come back. At the opposite end of the spectrum, you've got infrastructure and network and storage engineering people who are being beat up by database specialists because things aren't running as well as they expect. And there's a very broad spectrum, in my experience, of things that can impact our lives in that space. I mean, if we think about from the physical 10 upwards, you know, just the compute space, we've got memory, you know, RAM, if you like, disk space, network, and other bits around that. In disk space, we've got, you know, schools of thought that say that, you know, it's better to use raw disk or JBODs and just, you know, write as fast as possible to the disk and let the database sort out the data protection layer. Other people are big fans of RAID, the redundant array of inexpensive disks, and have different religious experiences with RAID 0, 1, 3, sometimes, you know, 5 and 6 different types of striping or replication on disk in case a hard disk fails. Even at storage level, at an engineering level, still we've got people who have different views and experience around performance on types of storage. So whether it's direct attached disks in the servers themselves, or whether it's connected by a fiber channel with a storage area network of some form, or whether it's storage mounted from a server somewhere via iSCSI over Ethernet, for example. And that's before you even really get to the database layer, where, you know, the sorts of things that we take for granted, you know, just maintaining that, as Eric outlined, you know, that what we call the conversation with your data, just being able to identify patterns and meaningful patterns that we think we can start to dive into and look for performance issues. I mean, it's a very broad topic. So I'm going to dive into 2 areas where, in my experience, time and energy and effort invested get some good returns. So let me just quickly skip to the first of these. I only half jokingly went looking for a picture of something that has skeleton on the inside and skin on the outside, but the Lego block was probably the least gruesome. But in many ways, this is how I kind of imagine and mentally picture the challenge that we face sometimes with analytics platforms and databases supporting them. And that is that you really only, as a consumer or an end user or even a developer, often see the veneer skin layer, but it's actually the skeleton underneath that's really the issue that you need to focus on. So, in this case, when we think about the things that can impact database performance and analytics resulting from the typical day-to-day performance hits, core infrastructure and just monitoring that core infrastructure, and as I outlined just a moment ago around disk and memory and CPU, and as Dr. Robin Bloor highlighted, challenges now with virtualization and things that are happening in the chips themselves, and performance down to core level, and the amount of memory that's now being put into each chip and each core. These are very technical challenges to look into for an everyday person. Keeping on top of query monitoring, one of the challenges around monitoring queries and query queues is, for example, SQL as a language and the database tools that come around analytics tools are very powerful, and particularly SQL as a language. But with that power and simplicity also comes a sting in the tail in many cases, and that is that if it isn't an application doing the same thing over and over and over, written by a good developer and supported by a good DBA, it might be people doing unstructured queries. And the problem with that is it's quite easy to learn a little bit of SQL and start making queries, but as a result of that, you don't necessarily have all the skills and experience and knowledge to know whether you're doing a good or bad thing to the database. So continually running the same big, broad, like star from can just take the building down. So keeping on top of, query monitoring is an interesting challenge. Just monitoring response times from the platform as far as what the platform is doing and what users are getting. Again, without the right tools, this is not something that you just intuitively look at the thing and think, oh, the network's running slow, or views in memory are not performing well, or indexes are performing badly, or plan caches are bloating. And then how do you get to the point where once you've seen an issue with it, how do you pull it apart and unbundle it and address the whole challenge of poorly structured queries? And is it an ad hoc query that someone's writing by hand, or is it an analytics tool with a dashboard front end that's performing badly because they're asking the questions the wrong way, or is it just a really, really badly written piece of code? And then doing that iterative, as Eric said in the setup initially, just iteratively going over and over and over and fine-tuning those workflows. What workflows am I running? How are they running? How often are they running? What code's running against them? Where are they running against it in CPU, memory, and disk and network? That's just a really, really technical challenge. And then the nirvana that people are looking for in this world of shifting from historical analytics and performance tuning and alerting against your environment, which is great to see because you might be able to plan in the future for it if you know why things went slow yesterday morning at 9 o'clock. But that doesn't help you right now, and it doesn't help you plan going forward. So things like capacity planning and sizing and scaling and tuning. So, I think there's a trend we're seeing now where there's a shift in very large environments where people have got big database platforms and broadly spread database environments to go from historical alerting and planning to predictive learning and planning, where they want to know what's happening right now and be able to plan for it going forward. Are we running out of memory, and are we going to run out of memory in the next hour? What can we do about it? What capacity planning can we do in the real time? Excuse me. So it gets to the point where, just the whole challenge of discovering these hurdles that get in the way of essentially what we refer to as fluid analytics, and making that the norm in your organization. As you can see, it's a non-trivial challenge for just the everyday great unwashed masses, and it's still a non-trivial challenge for even the more technically savvy. So, if it's difficult for mere mortals, how do we make this a thing that's possible? Because most of these are things that regular users can't resolve, and we may have some specialist database engineers, database developers, coders, developers, programmers, and so forth there, but they still really got to be able to unbundle the environment. They've got to pull apart, issues like people reusing code. One of the worst things that I've seen in this space around performance hits in analytics platforms and very large deployments of database server infrastructure is people taking a piece of code, a chunk of SQL or a stored procedure that they didn't write, and they don't know whether it's a good or bad piece of code, and they just reuse it because it gives them the outcome they want. But it turns out it may have been just something that was written on the fly to get one or two outcomes, maybe an end-of-year report. Someone was in a hurry. And so people using complex code they didn't write and just slap it into a piece of application development, not knowing that they're actually punishing the back end. So even just monitoring that performance hit and looking at where the queries are coming from and drilling down, that's an everyday challenge I see. Basic behavioral things like pre-staging data for performance where it's possible. Things that just experience only teach you, like deleting indexes if you're going to do bulk imports and then re-index so the indexes aren't being maintained when you're pulling in terabytes of data. You know, without the appropriate tools, that's almost impossible to see because you don't know the index is getting hammered. Optimizing indexes regularly is a sort of a 101. But what about, you know, when you do bulk imports or you know, creating a table on queries? If someone does a really big query, you know, that can be a massive performance hit. And again, if you're not monitoring, you've got the tools to see that sort of just happens in the background and you don't know how to address it. Limiting queries to just the number of columns you need, you know, it sounds really basic, but again, if you can't see it, you don't know what's happening, then it just happens in the background and it hurts you, it continues to hurt you. Knowing when and where to use temporary tables, batching up large deletes and updates, you know, all very simple things. But without that visibility, without the tools to do that, they just sit in the background, keep hurting you, and you just keep throwing more memory or CPU at a database environment to get better analytics platform performance, when really you should be able to drill into the detail of what's hurting you and address that particular thing. And then, you know, things like foreign key constraints and how do you find that? How do you even know that's an issue? So that brings me to the conclusion of my key point here, and that is that, you know, on a day-to-day basis, we see these problems all over the place. And as database environments get bigger and bigger and more broad, and as Dr. Robin Bloor highlighted, you know, we get more and more complex environments with multiple database types. And then also the need to integrate into some of the big data platforms like Hadoop and Spark that are coming along and more over time. It behooves us, in my view, to find better ways, in particular tools, to perform this real-time platform performance and analytics and diagnostics intelligently. Because it costs real time and real money and frustration for end users and real dollars if we don't start to get the tools to dive into these things. And with that, I'm going to hand over to our friends from IDERA because I believe they've got a good story to tell on how we might be able to address this very problem.
Sounds good. Thank you very much. And I will go ahead and kick things off. I've got a few slides here as well, and let me go ahead and kind of bring that up. Some of these we're going to jump through pretty quickly. Just to give you some insight, I'm the Director of Sales Engineering here at IDERA, and so what we do is kind of talk to DBAs pretty regularly about the pains and the challenges that they have specific to, in a lot of cases, performance monitoring and those kinds of things, obviously. And we hear a lot from that audience, and so I think I can share some of the information that I receive from them on a regular basis that'll make sense. I'm going to jump through a few of these because I don't think that they're real pertinent to the conversation. So, you know, I have my own list here of the responsibilities of the DBA. It looks a lot like Robin's list, and I think that it's pretty consistent. I think when you talk to a database administrator, though, it's always, you know, they're lumped into some of these areas more so than others, and there's no rhyme or reason to that. It just depends on the environment. I would say that, so you hear a pretty wide or broad range of things that people want to be able to do. And a lot of times the people that want these things they'll ask for them, and in some cases you start kind of drilling into what they're really asking for, and then you find out that they're really looking for more. They really want more information than what they initially think that they need, and when you start drilling into the tool, I think that's where you can start saying they're having a conversation with the data. And I think that's a real interesting phrase, and it makes a lot of sense in terms of being able to say, yeah, well, if you have a bad query, what is really a bad query? Is it a query that is consuming a lot of reads or writes or CPU? It could be one that runs a lot. It could be run, you know, that's, like you said, poorly written. So in terms of how we identify that, there's a number of ways that you'll see in terms of our product, the Diagnostic Manager product, that we show the DBAs how they can go about that. And it's real flexible. And I think that's one of the big things you have to have in a tool that's going to help you with these performance problems is everybody's environment's a little bit different. And there's going to be a lot of you know, needs and maybe even obscure requirements in terms of monitoring. So you got to have something that is flexible and something that is going to work and be able to conform to the environment that you're trying to manage. You know, and I'd have a lot of these examples. I'm not going to go through each one of them, but you need something that you can pivot back and forth between one piece of data and another, and I'll kind of talk about that when we get into the product a little bit and show you that in terms of how we do it. But the other thing that I think in terms of any good analytics tool is, there's some core things you're really looking for. You obviously, first and foremost, don't want a tool that's going to cause its own performance problems in the name of performance. So you want to, when I say collect the data at no cost, I'm not talking about the cost in terms of monetary cost, but in terms of the cost in terms of overhead and the cost in terms of the amount of resources that we're going to use in the name of performance. You definitely want something there that's going to help. You need something that's going to be able to get the data that you're looking for specific to the problems that you face within your day-to-day. And there might be some things that you don't need and that you don't want, and there's no sense in collecting that data if you're not going to ever report on it or going to have any needs around trying to manage that data in terms of the metadata associated to performance, for example. A good example is I don't need to be alerted if the distributed transaction coordinator service in SQL is down if I don't want it to be running in the first place. So don't alert me. Don't collect the data against it. I don't need that information. So having the ability to turn those things on and off is real important. The ability also to, once you do collect the data, having access to it pretty quickly. You don't have to, run and massage the data, manipulate the data. Being able to do it quickly and efficiently, and then once you have the data, obviously it's really important to be able to understand it. Now, this is where with like, for example, the Diagnostic Manager product I'm going to show you a little bit today, that product, I would love to tell you that product is going to replace and be a DBA in a box. The reality is it requires some knowledge of what your environment is, what you're trying to accomplish, having some obviously understanding of the role of the DBA itself is obviously important. Now, what we try to do is educate through the help and through other methods, but you're always going to want to tie this obviously with some type of experience levels or somebody that has some knowledge of what to do once they've receive the data, and being able to have a person that can ask the right questions to a product and having that conversation with the data is obviously key. And then obviously being able to make sense of the data. So once I have the information, being able to get that out to the right people, my developers, my operations team, whoever it might be, I might need to integrate with other products, having the hooks to be able to do that. These are all real important things. And then obviously, last but not least, if I need to know more, being able to do that, whether it means turning on some more to be collected on or whether it means just going to a little bit deeper into the data. You're hoping that with a tool that's going to be helping with performance, you're getting all of the things that you need to be able to answer those questions. The one thing that I didn't put on here that I think is probably worth noting is you need a tool that's going to help you differentiate what's normal and what's not normal. And I think that's a big one because, there's a ton of alerting products and things that are out there. But if you're getting an alert and the alert is a false alert, it doesn't do you any good. It's more of a waste of time. It's going to reduce your efficiencies more than it's going to help them. So, those are some things I would keep in mind. When I talk about the product that I'm kind of tying all of these things to within the IDERA product suite, it's the Diagnostic Manager product. I think that has probably the main kind of characteristics of what we're talking about here in terms of database tuning and performance and monitoring and those kinds of things. People are looking for enterprise level monitoring. They want to be able to have access to be able to, in one screen, know that things are working the way they should be, or they want to be able to, obviously, if there's a problem, to see where the problem is and then be able to drill down into it. Real big part of I think what people are looking for with these types of ways in which you can really hone in on your performance. The other thing that we obviously goes along with that is I can't just operate in the present, and I need to be able to go back over periods of time, whether that means looking at queries that ran poorly or whether it means looking at the way that the host VM itself was behaving in terms of resources. All of those kinds of things you got to be able to do, and you're not going to be sitting there staring at your console 24 hours a day, 7 days a week. If you're on vacation or if it's in the middle of the night, night or whatever it might be, you need something that's going to be able to go back in time with you to be able to say what was going on the instance at the time when we had a problem. And being able to do that, once again, efficiently and quickly and be able to drill down into it is definitely an important piece in terms of this discussion. And I'd say it's probably one of the more important things in terms of what people are looking for. They're always looking for that window into the past, because that's really, you don't want to have to sit there and wait for something to happen again. The last, or not the last thing, but the next thing on the list is really just tying back to what we were talking about earlier with the query performance itself. And I'm going to show you a couple of different examples within the Diagnostic Manager product how we do that, which really, at the end of the day, it's going to provide you a lot of options around the queries themselves in terms of what you want to gather, in terms of whether you're interested in queries that are causing resource pain, consumption of CPU or consumption of I/O, whether it's queries that take a long time to complete, or queries that just in general may not be the worst offending in terms of performance, but may run so frequently that the sheer frequency of it itself running could be a problem. And obviously being able to spot trends over time with those queries as well is an important part of it too. So there's a lot of different ways in which we can do that within this product, and I think that obviously that's a real important piece to most DBAs. And even if you don't have your own internally developed applications, it's still nice to be able to go to your software vendors and say, hey, you know what, at 2 o'clock in the afternoon every day when this job kicks off or whatever it is, it's your application that's causing this and we needed to get it fixed. So even if you don't have complete control over the code itself, it's still nice to know when problems are happening. And then, the other part is just obviously being more proactive, being able to be the first to know, being able to understand when a problem is occurring, to not only be able to be the first to know so you can correct it, but in a lot of cases what you need is something that will be able to automate a response in a lot of cases too. So you can say, rather than getting an email saying, hey, you need to go fix this, if I'm in a meeting or if I'm, on the road or whatever it is I'm doing, it's obviously very nice to be able to say, I've got something in place that's going to be able to address that in an automated way. And if it's not addressed in an automated way, at least being able to be the first to know so you can take corrective action or contact somebody that can. And so those are obviously big important pieces to, these types of problems you might run into in terms of the monitoring of your machines and your instances and the analytics themselves. Now, I talked about this earlier, which is the flexibility of things. I can't stress this enough. Being able to say, out of the box, if there's something that is not being monitored, being able to have the functionality within a product to be able to add those things to be monitored. And in the sense with the example of Diagnostic Manager, we have obviously, WMI counters, perfMON counters, SQL Server counters. You can create your own queries. You can even, if you want to pull the data from your vCenter environment or your Hyper-V environment as a result of the polling that's taking place, and being able to do that on a regular basis and pull that data and be able to view it. And once again, pivot from one place to another as you're looking at this information. So those are the kinds of things in terms of what I see people asking for when they're talking about a tool that's going to help them in terms of tuning and performance. The product I'm going to show you in just a second is Diagnostic Manager, and it supports everything from 2000 all the way up to 2016. It is specific to SQL Server, and so we monitor and manage those things. There's no agents on the instances themselves that are monitoring this, and so that goes back to collecting the information at a little cost. We try to, obviously, when we're gathering this information, not use a lot of resources to do so. We're trying to leverage the things that SQL Server is already providing to us and making it better, whether it's dynamic management views or whether it's extended events or whatever the case may be in terms of the collection itself. Being able to leverage that information and make it better is one of our mandates. Now, if you look through this real quickly, I'm not going to go through the architecture in too much detail, but have having a back-end repository with all of our historical data that you can manage and you can keep for as long as you want. You can even choose the type of information that you want to keep and for how long. So that goes kind of back to that, collecting the appropriate data and leaving the unnecessary data out. If you want to keep the queries for 5 days that are poor performing and then keep your alerts for 2 years, that's up to you, and that's completely your prerogative in being able to do that. Number of different consoles with this product. You have a web-based version, you have a thick client version as well, and so that's having the flexibility of jumping on a browser and seeing what's going on, or if you have a laptop where you have a dedicated client installed, either of those approaches would work for you. Now, what I'd like to do is kind of do a quick demonstration, and I would point out, and going back to this other slide here, that we do have, we've just added, just as an FYI for those folks that are familiar with the product, we have a new offering, which is the Diagnostic Manager Pro or Professional offering, which includes with that something we call workload analysis. And really it's about being able to interactively look at very large periods of time and go from that 30-day view to the 5-minute view in about 3 clicks, and being able to see the spike in performance or the problem in the bottleneck that you might be able, you'd be able to see at a very high level and drilling down to a very low level. And so I'll show you that as well today. That's new to the product. But what I want to kind of do is just kind of first start off, and I want to talk a little bit about that pivoting and going back and forth. And I've brought up an example, and I'm going to share out my screen here. And let's see. There we go, my screen. And let me know, guys, that you can see.
There you go.
Nice. Okay over there? All right, so what you're looking at right now, and this is the Diagnostic Manager product, and I just wanted to give you kind of a high-level demonstration of what's going on here. In this particular example, what we're doing is we're showing you the queries that are associated to weights. And so when I talk about being able to go back and forth, drill down deeper, and pivot, this view here is a good example of that. I can go from a timeline view like we see here, which is going to display now. In our case, we're looking at the weights themselves and the categories of the weights themselves. We can see the statements that are tied to those weights. We can see the applications. Notice it's on a timeline view here, so I can identify that information linearly based off of when the problem happened. But then again, if I want to, once again, pivot and I say, you know what, let's look at this from a different perspective. Let's go ahead and look at this from the standpoint of I want to see the queries or the weights or the applications that are causing me the most pain and rank them. And that's what we're going to see by query weights by duration. Now we're seeing the applications themselves that are causing me my most amounts of pain, or the weights. And then here's the part that's really the most important part, is being able to isolate these things. Well, I can see this OSQL application's kicking off here. It's causing me a good amount of wait time, well into the 25 seconds amounts of wait time within this 30-minute window that we're drilled into. And I can then isolate that application, and I can see the statements, in this case, that are directly affecting this particular instance. And so this is just one example of how you would be able to identify a bottleneck, be able to rank the information, being able to prioritize the issues that need to be addressed first. These are all things that you have to consider. It's, you can fix problems all day long, but if you're fixing the problems that are at the bottom of the list to be fixed, then you're wasting your time, and you have an opportunity cost associated to that. I'll give you another example, and this is a little bit of a different example. Rather than specifically pointing to a problem or pointing to an area, you also need a tool that's going to be able to help you in a broad sense and being able to say, hey, have we had any problems, or are there things that I can do to improve the performance, and to have something kind of behind the scenes watching what's going on. And in this case, this could be related to the configuration. It can be related to the, the way in which the health of the instance itself is being managed, and also obviously performance things as well. So if I go to this Analyze button over here, the thing I'm going to show you is that within this product, we also have kind of a proactive listing of things that can be performed in a ranked format that will essentially provide you insight into the things that will likely give you an increase into your performance on that instance, or an increase to the health of that instance. And it's in a ranked format in the sense that you have that ability to see which ones are more likely to improve your performance specific to a particular type of problem that's been identified. And so when I look at these things and I identify them, not only do I see that I have a problem, and I have also, in a lot of cases, a script that can be built automatically to fix that problem. But in many of these cases, we also have external links that will reference the type of problem that we're experiencing and then why we're giving this recommendation as well. So you get that educational aspect of things, which once again I think is very important when you're talking about, you know, fixing problems. If I don't want to just blindly follow these recommendations, I want to understand why these recommendations are being made. And I might be a senior DBA that's been doing this for 30 years, and I need something that's going to, you know, check or dot the I's and cross the T's in this case. Or maybe I'm a junior DBA and I need a little bit of help in terms of understanding these problems as they're happening and why these recommendations are being made. So like I said, I'm just going to take you through a couple of different parts of the product. This tool's been around, you know, it's been around since 2004, 2003. And it's got a lot of, it really has a lot of development put into it, a lot of information. So it wouldn't make sense to try to show you everything here. But I think one of the things that's worth noting is that when we go in and we start talking about all of the things that you can monitor and all the things that you can alert on, once again, going back to that flexibility of things, here's a listing of all the items that we are monitoring. Now, it doesn't necessarily mean I want to consider these things to be in an alert state if they get out of whack in terms of the threshold. So you can turn these things on and off. So this goes back to that, hey, I only need to do certain things to certain metrics. I only need to, you know, alert on certain problems and be able to make sure that we're not going to, you know, saturate you with a bunch of false positives. So not only do you have the ability to turn these things on and off, but in many cases, you'll notice that we also provide that band of normalcy as it relates to each metric. So if I'm looking at this particular, in this case, a baseline, I would notice that the threshold's probably higher where they're at right now. On the other side of the coin is, what if I have an instance of SQL where I'm tracking some metrics, and those metrics, for whatever reason, the thresholds I've set are incorrect? In other words, the thresholds are smack dab in the middle of where the baseline is actually sitting, which means if I have an alert tied to that threshold, I'm probably going to be getting an alert for something that's a normal event. And so in those kinds of situations, we can provide you that insight as well across the board. So for all of the metrics on this particular instance, I can see those thresholds that are probably likely going to show a false positive here in terms of what's normal and what's not. This is going to be something that would be considered more of a normal usage thing on the memory side. And if I wanted to increase that threshold, I could. But that's kind of the idea with the baselines. And the cool thing about the Diagnostic Manager product in terms of the baselines themselves is an ability to set multiple baselines. Now, you might ask, why would I want to do that? And the answer is, well, if you have a maintenance window that runs from, let's say, midnight to 4 a.m., where you're really taxing your resources, you're really using the resources as much as possible, then you want to be able to, once again, shift, and you want to pivot a little bit and say, look, we're going to change our thresholds for that. And we can actually dynamically adjust our thresholds particular to whichever baseline we happen to be in based on the time of day or day of the week and so on that it is. So it'll dynamically adjust those thresholds for us. Now, let's take a step again. Once we've identified those thresholds, once we've gone through, and in terms of setting up alerts and notification and being apprised of these situations that might happen, once again, flexibility is paramount here. You want to be able to alert in specific situations. In other situations, you might want to send an email to somebody else. You might want to run a PowerShell script. You might, you know, the list goes on. I might want to integrate with something via an SNMP trap, or even directly with, for example, SCOM. The point is, you have the flexibility to do that, and you can set up whatever types of conditions would warrant that. Whether it's a very broad reaching condition, you know, my CPU and memory or whatever resources across all of my instances, or maybe I have a very specific type of thing I want to monitor for, because when I find that we're in violation, I want to run a very specific and directed script at that problem. So this is where you would be able to do that kind of stuff inside of the Diagnostic Manager product, is, you know, in terms of the alerting and the notification, and being able to be flexible from that standpoint. Now, I won't go through all of the alerting and all of that good stuff. I did want to talk about the reports, and once again, being able to take the information and leverage that data in a number of different ways. And this goes back once again, to the conversation with your data. And a lot of people, when they first see this product, they think, oh, well, I'm going to have a tool that's going to alert me when there's problems. That's what I need. And the reality is they need that tool, but the other side of that is that they also need a tool to help them make decisions, and they can leverage this information that we're collecting in the name of performance and also in the name of alerting to be able to help you make decisions down the road moving forward. You know, a good example would be my growth forecasts within my database. If I have a specific database that's growing, being able to point to that database or even multiple databases to be able to see what the growth rates are. It's not showing you based off of what what it is today. It's going to forecast it out based off of the past growth that we've experienced. So if I've got a few databases here, which I happen to have, imagine that, I could go in and say, let's take the last year's worth of data, let's correlate that by month, and in a sample rate of months, let's go ahead and see how much growth we're going to see in the next 3 years, or 36 units, in which case we could very quickly answer that question. Now, try to do that on your own, right? Try to do that in as much time as I did it in on your own. It's going to take you a while. Now, to even kind of further stress that, let's take another report, which is my top servers report. Imagine I have 100 production instances, which in this case I don't. But if somebody comes to me and says, I need you to tell me, we're going to put this new database out there for this great new application. It's going to change everything as we know it. It's going to make life so wonderful. Oh, by the way, the database itself is going to be really I/O intensive, or it's going to be really CPU intensive, or really memory intensive, whatever fill in the blank it is. I want to be able to see, of all of my production instances, where does it make sense to put that database? And I can rank all of my instances against each other in terms of the contention type, whether it be CPU, memory, disk, or whatever the case may be. And so the point here is being able to answer that question quickly and efficiently and making the right decision rather than guessing when you do it. Those are all obviously real important, and you need something that's going to help you. And when we talk about analytics, it can range from everything like what we're talking about with capacity planning to the alerts that you're running into on a day-to-day basis that might deal with CPU, as well as obviously the queries themselves, whether there's blocking and so on and so forth. And another example of that would be, if I went to the administration section over here, actually I take that back, the alerting section over here, querying the repository of our historical information for things that have happened in the past. Have I had blocking that's occurred in my production environment? I don't know. Let's find out. So I can go out to my production tag, and I can say, for all of my production instances, given whatever period of time, for any metric that I want to identify if I've gone into an alert state on, in our case, let's say blocking by count, not by seconds of blocking. And I can go back, in this case, a few months if I need to, or in this case, 1 month, and I can see that blocking. I can see when it started, I can see when it ended, and I can drill down into any of these polling intervals if I need to see the specifics of the blocking incident itself. So you need to be able to have something that's very quick, being able to find what you're needing and looking for rather than spending a lot of cycles to do it in. And so I think that's also important. So the last thing I want to kind of show you in showing you this product, the Diagnostic Manager product, is we have, as I mentioned before, we've gone in and we've added another component to our SQL Diagnostic Manager Pro offering, and that's the workload analysis component. This is a web-based version of this, in this case, that we're showing you here. But the point here is that this allows you to look at a really broad period of time or a very specific window of time, and from a few clicks being able to see the code directly related to problems that might have happened. So as an example of that, if I'm looking at a 4-week view, here I can see right here all the spikes in terms of the databases and the performance of those databases and where we saw wait activity on those databases. Now, you can see, if I see a spike here, the benefit of this tool itself is just being able to highlight that bar right there. And then when I do that, all of the stuff over here changes. We would be able to see the databases. We would be able to see the commands tied to what's behind that bar. Same thing if I said, let's look at the last 4 hours rather than the last 4 weeks. I can still do that. I can still highlight that period of time, and then from there, here's once again, here's my pivot points. All of these things here I can link to. The top SQL statements, I can see those queries. In this case, they were causing weights that were related to CPU consumption. Just by drilling in, I can see those queries related here. Whoops. And I can also see the programs and whatnot associated with this as well. So you got a lot of insight here. And not only that, but you can see when you get down to the command level, it's going to tell you things. It's going to tell you whether it sees heavy operators. You can then view the execution plans. It's taking a little bit of time because it's pretty extensive to load this one. But the point here is that you have a lot of different ways to view the data, to see what it is you're looking for, and then obviously be able to take action from there as you need to. So, and this one's taking longer than it normally does, but I'll leave it at that. And so with that said, I'm going to pass it back over. Hopefully this was a good demonstration of kind of the things we were talking about. Like I said, the product itself that we were using to kind of give these examples has been around quite a long time. And so a lot of other things we could talk about and show you, but if this is something that is of interest to you, you can always go out to our website and download it and play around with it.
And I love that you show all this detail. If you go back to a couple of screens, even this screen is pretty good, because there are so many different ways to visualize what's actually happening. And I think this is one of the more underappreciated aspects of computing these days, and certainly of database environments, that in many ways, I have this half joke. I say we're still learning to speak silicon. You know, we're still learning to understand how to see what's happening. And to your point, which is very well taken, you need to have that conversation with data to better understand what's going on, why things are going slowly, because there are so many possible problems. And of course, IDERA's got a number of different products, one of which is the old Precise product that I think could be complementary to this. But maybe, Robin, I'll throw it over to you for a couple of questions, and then Des, a couple of questions from you, and then maybe anyone from the audience. Don't be shy. Send them in now. Robin, are you on mute?
Yes, it's all right. It's all right. I've just taken myself off mute. I must say, it's incredibly. The thing that actually struck me as most dramatic about this tool, because it really, especially given the fact it's quite obvious that a whole series of dimensions you just didn't go into. The thing that actually I think were most impressive about this is it must be a really, really good way to train a DBA. You know, it's like when you first get into doing database work and you actually don't know much about what is actually happening in a database, it is actually really, really hard to get an understanding. So is this used a lot specifically for training? I would use it.
Yeah, I mean, when you say training, I mean, you mean kind of like a training in progress as a DBA kind of thing, right?
Yes, yes, a learning tool, you know.
Yeah, I would say for sure that's the case, and even more so that we've added the Analyze component that we were showing you earlier that has all of the recommendations that are tied to it. But I think for sure you'll find within the help and a lot of different areas within the product, it does provide you with you know, a lot of insight, a lot of information. And the reality is, like I said, you can use this if you're not a DBA. You'll probably find yourself doing some Google searches and things like that, just to the general knowledge of what most DBAs have. But you can correlate this, and it's definitely going to help you in terms of, hey, you know, hey, what's this thing called fragmentation? Or, you know, why is this query running 6,000 times? I mean, because those things will be brought up to you, and they will bubble up, and you will see them. You'll see your you know, what's normal, what's not. You'll see the things that are spiking, the things that aren't. As a rule, we try to set this thing up as in terms of best practices, so that when you point it to an instance, it's going to show you the things that are identified as outside of best practices. I mean, of course, you know, the reality is that best practices is best practices, and it's not always real practices. But you know, it will show you the outliers even from the initial point that you install and point it to an instance. So, and then from there you can kind of move along as you need to necessarily to fix the problems and identify whether that's really a problem or something that's normally happening on a day-to-day basis. And then because you have a lot of information in the help and the recommendations, yes, absolutely.
Right. Right. Another question, but I'm sure the answer to this is very swift, is that you do have the granularity to go right down to the individual query at an individual point in time and look from that dimension.
Sure.
That's the case?
Yes. Yeah, I can. It depends. Depending on what you're wanting to do, you can look at a 1 minute window of time, or you can look at a 3-day window of time, or a 3-week window of time. And like I said, it depends on how you want to look at the data and also what you want to collect. In some cases, we only collect the queries that are reaching a threshold that you've identified. In other cases, we might collect every query that causes a wait. But you also have the ability to say, look, those thresholds that I identify, maybe it's just for writes, or maybe it's just for reads, or maybe it's just for CPU. So assuming that it's surpassed that threshold, and that's what you want to collect on, then whatever time frame you want to look at, you would be able to see those queries that are offending based off of what you consider to be offending. So you have a lot of different ways to look at the data. You can look at it in consolidated view to see the queries that, how many times the same query kicked off versus, every single incident of that query kicking off, to watch a pattern, if you will, to see if it's continually getting worse. But to answer your question, you can definitely point to whatever time you want. You have this thing called the history browser. And I was kind of using it a little bit, but basically whatever point in time you select, whatever day on the calendar that you select, you can go directly to that point in time. So right now I'm looking at November 15th at 7:05 p.m. and we can look at queries specific to that time if I had any that were running poorly given that window of time. We would be able to look at the session details specific to that window of time to see what sessions were running. I mean, there's a whole slew of data here, and like I said, the hardest part really is that the maybe 30 minutes of playing around with the console and figuring out how to do this stuff. But once you recognize that most of the data here is in this ribbon and it's divided by these tabs, and each tab has its own set of dynamically changing buttons that appear every time you click on it, then whether you're looking at real-time stuff or stuff that happened last week, it's the same process. It's basically, I'm looking right now November 15th, but I could just as easily look at the real time just by clicking on that button. I'm going to interact with the data the same way. But to answer your question, yeah, there's a lot of different ways to view historical information, and that also pertains to the queries themselves.
It's very impressive. And I love the fact that the windows synchronize, even though that's kind of become pretty much necessary in anything that's dealing with real-time data nowadays.
Sure.
Here's just a point of information that I actually don't know the answer to. Azure offers SQL Server in the cloud. Can you point at the cloud under Azure?
You can. You can point this under the cloud. When you actually add instances, it'll ask you if it's RDS or Azure. Now, there are going to be some limitations based off what's being exposed to us from the cloud. There might be there's a little bit of a difference in terms of what we can monitor, simply because the instrumentation in some cases isn't there for us to gather based off of what Microsoft is exposing. Now, if it's something like infrastructure as a platform, like or EC2 or something like that, that's not a problem at all. We get everything. And as we work with Microsoft and we work with Amazon, we're working to expose that information in more detail. But absolutely, yes, we do support those environments.
Okay, that's interesting. Well, I'll hand on to Des, who I'm sure will throw you questions from a different direction.
All right.
Thank you. I've got two very quick ones for you. I think the first one is the scale. I think one of the things that strikes me is that the general theme of sort of performance tends to be something that we think about when we get very big, very large scale and broad. And beyond terabytes of data. But watching the demo, it struck me this is something that actually applies to even very small environments that are just getting performance hits. What kind of spread do you see in the uptake of this? And do you think it's a tool that has a good, in my mind it does. So I think it's a yes. But I'm just keen to see whether you're seeing that smaller organizations are having the same performance hits and looking for a tool to do this, or is it really something at the bigger end of town?
It's funny. It's a good question. It's a little bit of a mix, but I'd say that we have a ton of small customers. And when I say small customers, I mean 1 to 5 instance purchases to license to manage. Now, in some cases, they might have 30 instances, right, of SQL, and they only really care about the 5 really, really importantly enough to invest in a tool like this for those 5 instances. But the reality is that even the smaller shops, you've got a handful of SQL servers out there. In most cases, or in a lot of cases, that small shop is very, very dependent on those databases because of what they do, and so they can't let it go down. They have to have a tool. The other side of that coin is that in some of those smaller shops, they don't have dedicated DBAs, so the guy that's the smartest guy in the room or the more technical guy in the room ends up being the assigned DBA. And so in that situation, they're definitely looking for some help, and this tool will obviously help them in that regard as well. For your larger environments, as I think it was Des that mentioned it, or Robin, I'm not sure, but the larger environments, you'd be surprised at how many DBAs they have. I mean, we're talking huge numbers of instances of SQL, and you've got literally handfuls of DBAs that are tasked to be responsible for them. And so from that perspective, those guys, they're looking for some help because they don't have the resources really adequately enough to really help them, and so that a tool will help offset some of that. And so we see that quite a bit as well, where you've got 3 guys managing 300 instances, and so you can imagine the logistics of that if you don't have a tool like this to try to figure out when even there's a problem. It's not going to be a proactive way, I can assure you. So, but hopefully that answers your question. Yeah.
It does, yeah. Because it did strike me, and I think Robin sort of alluded to it, that the sort of performance hits you're describing when you did the demo. I mean, they're not exclusive to very large environments. You could buy a common off-the-shelf platform that's designed for one thing and put it into a database shared environment for something else, and it'll just punish the entire environment. The other thing, I guess, is the other thing that struck me, it's not so much a question, but just an observation, but I'll lead it to a question, though, and that is that when organizations have already made an investment in their infrastructure and their platform and their database, and the servers and infrastructure around that, and then they go and buy a product, whatever it might be, a HR or ERP or BI tool, they've already kind of made a fairly big investment. What sort of response do you see when you have a conversation with people and they've realized they've got a performance issue, but they feel now they've got to make yet another investment to get to it? Is there a point where they realize once you demo it that the ROI in this thing is a no-brainer, and it's not so much a sales pitch, but it's more of an epiphany? It just says, you know what, we're immediately going to see benefit from this, as opposed to just having to sell the product. It seems to me that it sells itself, and the ROI just jumps off the page.
Yeah, and that's funny you say that, because what a lot of times will happen is that somebody will, like a DBA or even the sales reps will come and they'll say, hey, these guys want to see like an ROI sheet on this, and more like something on paper that we would send to them. And the demo is always 10 times better, especially if you can do it with the DBAs themselves, because like you said, the product sells itself. It's really hard to put an ROI on a piece of paper and say, okay, how many clicks does a DBA typically, click in an hour as it relates to backups, or whatever the case may be, and trying to put that on a piece of paper, it's really hard to do that. But when you get somebody and you show them the product and they see it, it's exactly what you said. People realize the value of it, because not only is it helping them to understand and make better decisions, but it's also helping them to not be the bad guy. They can be the first to know. They can correct the problem before it's ever even identified that there was a problem. The other part of that is that as a DBA, whether it's a real or perception, and I think it's perception, you own the performance problems, really. You're the guy that gets the finger pointed at you when the performance goes down. And the reality is it could be the developer that really is causing the problem. So having a tool to be able to say, hey, this is not my problem. I need to be able to take this to the developer, and they need to correct this, or along those lines. It's a nice way to be able to have something in your arsenal to be able to say this is where the real problem is,
The last one for you, and the thing that strikes me looking at this as we went through it, was that often when we think about performance issues, we tend to bring in specialist skills. They come with 20 years of experience. They look at it, and they sort of that classic joke of the guy that walks into an engineering shop and has a tiny little hammer and hits the machine on the right spot and says that's a $15,000 fix. And people go, we're not paying for that because it's 5 minutes of the work. And he says, well, that 5 minutes work took 15 years of experience to fix, and it saves you millions. To me, it seems like, you know, there's a mental process of people go through this thing of saying, okay, bring some special skills in, fix the problem, now go away. But what they've done then is they've just put a Band-Aid on it, right? As opposed to a scenario where, from what I can see here, where when this goes in, yes, they may have addressed some performance issues that what they thought they were experiencing. But it seems to me this then just has this 24/7 kind of, you know, sort of eyes watching the environment real time. So you end up getting away from the scenario of DBAs being woken up at 4 in the morning because reports aren't running. Is it the case, and maybe it's rhetorical, but is it the case that people quickly transition from looking to invest in the product to get it to solve a particular problem, but then it just generally becomes part of their DNA?
Yeah, and it varies from place to place, but I mean, I've got some folks that initially purchased their product like back in 2006, and they've been to 3 different jobs at different companies, and they've gone in, and when they go to that next company, they promote this as something to get because they have a workflow, and call it that. I hate to call it that, but you know, that workflow involves this product, and they're used to it on a day-to-day basis, and it helps them. And so they don't want to learn something new. But absolutely, I mean, most of the time we get people to download this product. It's not because they have a budget and that they're going out and they're saying, hey, well, we have this performance budget. We need to do a proof of concept, and we need to step in and figure out and do an evaluation and all that stuff. Usually what happens is they've got a problem on an instance of SQL, and they're looking for some help to fix that problem. They go and download our tool. They get the problem fixed, and then they realize that the tool itself is going to do more than just fix the problem that they had at the time, that it would actually help them improve the overall performance and keep other problems from happening moving forward. And that's for sure. And that you can definitely keep using this tool to continuously tune the environment, because you're always going to be able to see not only what happened right now, but what happened last week, last month, last year, and compare that to what's going to happen tomorrow, you know, that kind of thing.
Yeah.
So for sure.
Perfect.
Yeah.
So you mentioned something that I'm just going to wrap up on before I hand back to Eric to close. But one of the things I'm always interested in is how do people get their hands on it? You mentioned download it. What's the 30-second summary of just how they get their hands on it, get a copy, spin it up and play with it, and what they might need infrastructure-wise to just get an instance?
So that's going to be, if you go to IDERA, IDERA.com, IDERA.com is the company, and if you hit that website, and I can actually show you here, I don't know if I'm still sharing my screen, but if you go to the products page, then go to the Diagnostic Manager link, there will be a little download button, and you can just download the build after you fill out your information. It'll ask you for the 32 or 64-bit build, and you're off to the races, as they say.
And will it run on a laptop for someone to play with it, or do they need to load it on a server somewhere?
No. In fact, what I showed you today was all running from my laptop. Now, my laptop has 32 gigs and it's an 8-core processor, but it's still a laptop. But it doesn't necessarily need to have that much resources, to answer your question. And it's good for the evaluation itself is good for 14 days, but you're more than welcome to give it a longer trial. If you just give us a call, we can extend that for you if you'd like.
So I think that should be something to take away, because I'm definitely going to do that. I think, from the looks of things, it seems to me a no-brainer. Download it and play with it. Poke it at one of your environments and just see what you can see, because I suspect that, like everything I've seen in database background the last 20-plus years, which ages me, once you get to see what's under the hood, it's amazing what you realize you can fix quickly and just get little gains in performance. And awesome. Well, thanks for the demo. It was really great. Thanks for all the time to discuss the question.
You're welcome. Thanks for
Eric, I'm going to hand back to you.
Yeah, we do have a really good question from the audience member. You kind of talked about this in your presentation, and I actually tweeted about this because it was such a great quote. You said you don't want to be using a tool to monitor performance that impacts negatively your performance.
Right. That's right. Yeah. That's kind of an important part of a performance monitoring tool, is it doesn't cause performance problems. That's exactly right.
Exactly. Well, it's like those darn, it's like the antiviral programs, which can just wreak havoc on systems. I mean, I've used a number of different technologies for broadcasting where the antivirus program kicks in and will truncate your stream. So, there are things that happen that you don't expect, but the question, it relates to that specific comment you made, and what kind of performance hit do you see? Is it 2%? Is it 5%? Is it 1%? Do you have any numbers you can throw at us?
So, I mean, the challenge with this question is that, you know, part of the discussion we were talking about earlier, I can give you it's usually around 1 to 3% to answer your question, but there's a more explanation that I think would be required, which is we provide you a lot of ways to be able to tell the tool what you want to monitor, right? And so it goes back to that, well, I might want to get a sample of every query that's running. So I want to have a tool that's flexible enough to be able to turn that on so I can see that. And so part of that flexibility includes, you know, there's a cost to it. If I need to collect more data because I want a sample of every query that's running in the last, you know, 20 minutes, I can turn that on and it can do that. And so, but generally speaking, yeah, 1 to 3% is what we see in terms of overhead. But that's going to vary, and most of that's going to be dependent upon your things that you turn on and turn off in terms of your thresholds, how much data you want to collect, your polling intervals, all that kind of stuff ties into that. In fact, if you go out to the instance itself that you're managing, one of the things you'll see is we have multiple polling intervals that you can specify. And that's simply because we want to, you know, I don't need to check, if I want to do a heartbeat check on an instance, I don't need to pull the CPU and everything else along with it if I'm doing it every 20 seconds. So you have multiple polling intervals that you can specify. You also have, like I said, your query monitoring that you can specify. And this can be done for each instance independently. So you can really cater to that specific instance in terms of what you want to monitor. For my weight statistics and weight monitoring, I can turn that on or off, and I can tell it to capture everything. I can tell it, you know, what I want to capture, when I want to capture it. So a lot of that will also, you have to take into consideration what you're doing in terms of what you're telling the tool to monitor. But generally speaking, what I would say is, like I said, around 1 to 3% is what we see. We've been selling this tool a long time, since, like I said, about 2003 or 2004, and we've got thousands of customers. So I can assure you that, you know, we don't have, we try our best not to cause performance problems in the name performance.
Yeah, that's really good information, and I just thought that was a brilliant quote because, you know, again, you don't want to defeat the purpose of what you're trying to accomplish, right? And I appreciate Robin's question too. This really is an excellent platform for helping DBAs understand the many different aspects and dimensions and layers of what we're talking about, and I think the concept of conversation with your data is highly appropriate here because, to your point earlier, you're not going to figure it out on the first try. Usually, you need to spend some time looking at the data, looking at the historical data, doing that synthesis in your mind, and that's the job of the human, right? It's the job of the professional who sits back there and takes heat from the business on a fairly regular basis to get that job done and to keep the trains running on time, right?
Absolutely.
Well, folks, this has been another fantastic event. If any question you asked was not answered, by all means, let me know. Send an email to info@insideanalysis.com. We do archive all these events, so you can always go to insideanalysis.com to find the archives, or go to our partner, Techopedia.com. If you look at the right-hand side of their page, you will see events, and the webcast listed there. If you click on more events, you can see all of the webcasts that we do listed there, past, present, and future. And with that, we're going to bid you farewell. We've got 5 more webcasts for the rest of this year, folks. We may schedule 1 more, but otherwise it's going to be on to 2017. The EdCal is out. Let us know, and if you have someone who wants to showcase their technology, send an email to info@insideanalysis.com. With that, we're going to bid you farewell, folks. Thanks again for your time and attention. We'll talk to you next time. Take care. Bye-bye.